Hi, Kasam. Shall we start or we wait for 5 more minutes?
We can start, Mandar.
Thanks, Kasam. Hello, everyone. I hope everyone is doing well and taking care of themselves and their families. Indeed, bad times we are in these days. But thank you all for joining today's session, and I hope that it proves fruitful and you get some insights from it. Today we'll talk about the Azure Integration Services suite offered by Microsoft under their Azure umbrella. And as the title suggests, this will be an introductory kind of session and will contain basic demos. After this session, if you guys are interested in learning more about it, just let me know on LinkedIn. Probably I can help you out, or you can let Kasam know about it. Probably we can get some other advanced session going on at a later point of time too. So a little bit about me. My name is Mandar Dharmadhikari, and I'm a technical consultant currently working with Chamonix IT Consulting Private Limited. We are Microsoft Gold Partner for Cloud Platform and Application Development, and we are also Microsoft Silver Partner for Application Integration. I'm connected today from the beautiful city of Churches, Adelaide in South Australia. I make my living by developing enterprise integration solutions. In my free time, I like to write and read about integration and AI offerings from Microsoft in particular. And on personal side, I'm a diehard fan of the band Metallica, Game of Thrones, and the Dragon Ball anime. And I also like to cook. Following are my contact details. So that's my GitHub repository. You can connect with me on LinkedIn, and my Twitter handle is @the Abbot of Code, the site on which I started blogging few days ago. So takeaways from today's session, what you can hope to learn about. So we'll see why integration solutions are required in an organization. We'll see what are the different components of Azure Integration Services. We'll take a look at the basics of Azure Logic Apps, Azure Functions, Azure Service Bus, Azure Event Grids, Azure API Management, and then I'll explain 4 or 5 demos. 2 of them will be targeted toward people who are not integration development. 2 of them will be a little bit integration concept heavy, and 1 of them will be just a simple one. And once that is done, I'll share the links for further reading, and we'll take some questions. So what is integration? Well, for any big or small organization, there are various systems and components that are always at play. On one side of the spectrum, we have the customers. We have the third-party agreements that the organization has with other companies for the data exchange. Then we have the intelligent assistants like the enterprise bots, chatbots, or even assistants like Corona, which provide value and support to the customers. And we have our classical websites and mobile apps. These components are mostly front-ended and require and involve heavy user interactions. On the other side of the spectrum, we have systems which facilitate the machine learning and AI systems which analyze huge amounts of data. We have third-party software as service products that are used in a particular organization. For example, it would be Salesforce, Dynamics 365, SAP, etc. Then we have any containerized applications or any in-house application that the organization builds. And we have the data that is generated due to all these activities inside the organization. In such a complex ecosystem, none of the application or none of the block that we have seen just now can work in silos. Well, these systems need to communicate with each other, and through this unification, the organization can provide business values to its stakeholders. So integration in nutshell provides the ability to unify these disparate systems and make them function as one and deliver the required business value. So simply summed, integration services stands in between the front-ended applications and the back-ended applications, and they talk to each other through integrations. That's the very high level idea. Even integration services allow communication between two back-end services or two front-end services. So it's just mix and match of what our organization requires. So we can see that integration really plays a very important part in the organization. Well, based on these needs of integration in a big organization, following are the expectations that one can have from the modern integration platforms. Well, the modern integration platform is supposed to deliver or has the ability to securely expose APIs to the external and internal systems, because APIs today have become a norm in which organizations interact with each other. These APIs can be HTTP based REST APIs, or they can be gRPC or GraphQL type of APIs, but the modern integration platform needs to have a way so that the APIs that organization develop can be shared with either its internal teams or the external ones in a secure manner. Then the integration platform should have the ability to orchestrate business processes and automate the workflows and tasks. And the integration platform needs to provide us with a secure and reliable messaging system to enable cross communication, cross systems communication that we just saw. And the last ability and the last important ability that it has to have is ability to support a reactive style of programming through the use of events. So this is one of a solution architecture style where the communication between the different systems happens through events. So modern integration platform is supposed to have that ability too. Then another underlying requirement is that the platform should provide a ease of development, because if we have any bespoke or integration developers in our midst today, surely you can understand the pain that you had to go through to get on board and learn the integration technology, because the learning curve is quite steep for that. So the expectation nowadays is that developers should be able to easily develop the code. Another related requirement from that is the onboarding time required for new developers to join the team and provide values to the current integration is expected to be very less. So these are kind of linked with each other. Then codeless is the norm today. Most of the people expect integrations to be drag and drop. Of course, that is not the case always, but it's expectation that the developers should be able to develop the integrations without writing too much code. And it should support all integration patterns as well as the modern ones. So when I say old integration patterns, I'm talking about EDI exchange between two systems, partner to partner exchange of data. Then we have the SOAP-based communication between the target system and the audience system. We have the REST-based. We have WCF-based. So the platform should be able to support the old as well as the new integration patterns. So Microsoft has excellent suite of services that answer to the expectations that we just saw. This suite is called as Azure Integration Services, and it has following components to answer to the requirements that we just saw. So it has Azure API management to securely expose the APIs for the external and the internal use. It has Azure Logic Apps, which provides an intuitive and easy way to create integration workflows in cloud. Then we have Azure Service Bus, which provides enterprise-grade reliable messaging. And the last one is we have Azure Event Grid, which provides the Azure ability to develop reactive systems based on the events. So what was the vision of Microsoft behind developing this Azure integration based on the requirement given previously? Microsoft wanted to make the new integration platform easy to play with, easy to develop with, because the classical integration platform offered by Microsoft is BizTalk Server, and it's a really great product, but the learning curve that one has to go through to learn the nuances of BizTalk is just too steep, and that would take a lot of time. So Microsoft wanted to kind of reinvent their integration platform so that it becomes really easy to develop integrations, then make the integrations codeless as much as possible. Now, it's not always possible to have a codeless integration workflow. You might be required to have some auxiliary calls to other systems and C# functions where we want them to do particular things, but that's just the top of the thing. But most of the code or most of the integration that they wanted to have was codeless. Then they wanted to go along with the integration platform as a service style, because in the current Azure Integration Services suite, most of the things or the most of the backend management of the, be it Azure Logic Apps or API management or Azure Service Bus, is taken care of by Microsoft. So it's a platform as a service which is offered by them to us. So that was their vision, to offer a platform where the developers would not have to think about maintaining their servers, patching and fixing vulnerabilities and that kind of things. And that basically enables faster development and release of products. And another vision of them was to be a leader in the field of integration. So now, that being said, let's quickly take a brief look at the different components of Azure Integration Services. So first one is Logic Apps. So Logic Apps resides at the heart of the integration platform as a service story sold by Microsoft. Logic Apps are basically integration platform as a service. They are completely serverless, as the Logic App runtime engine is completely abstracted from us, and it is maintained by Microsoft internally. This makes Logic Apps a true platform as a service offering. They allow us to have automated workflows and allow us to orchestrate business processes. These integrations can range anywhere from simple data management integrations to enterprise level integrations to business and even application integration. Logic Apps work with designer first approach of development. It is quite similar to the drag and drop approach we had while developing the ASP.NET websites in the past, if anyone has used it, or even if we have any BizTalk developers, it's like developing orchestration in that case. So it's kind of a platform where you develop workflows by adding actions and shapes in the portal itself and not writing much of the code. So Logic Apps, apart from this, has more than 300 plus inbuilt connectors for integration with various systems. So these connectors range from connecting to Salesforce, OneDrive, Office 365, Azure AD, Azure Functions, MySQL, then even Oracle, SQL Server, so on and so forth, SFTP, FTP, I can keep on counting, and they are adding newer and newer connectors day by day. So these inbuilt connectors provide us the ability to develop really lightweight integrations, because most of the backend handling and the call to the actual system is taken care of in the backend. So you just need to configure a few keys and few headers or even few values, I would say, and that's it, and you are good to go. You have an integration with that system, so it's that easy. and the integration becomes really lightweight. And all of these calls are done based on APIs. So Logic App, basically the backend works through API calls throughout, end to end. Logic apps then work with pay-as-you-go structure, so you only pay for what you use. You're not charged any hidden costs or anything. Apart from that, Logic apps are templatized, meaning we can use Azure Resource Management templates to deploy Logic apps into cloud. And at the same time, Logic apps internally provide various integration templates for common integration scenarios. So this feature really lets the developer who are not familiar with the concepts of integration to develop the workflows really easily. Then there are rich features like the integration account, which stores your transformation maps for XML to XML, JSON to JSON, JSON, XML to JSON, that kind of maps. It has agreements that you can store for interaction between two business to business parties. You can store schemas in the integration account. You can perform validation against those schemas. All these rich features are provided by the integration account. Logic App has inline code capability so that you can write small chunks of code in the portal itself and execute them in the context of the workflow. It has then on-premises data gateway to connect with the systems that are placed on the on-premises. And it also allows us to create custom connectors other than the three inbuilt connectors that we have. So these features really make Logic App a suitable choice for a hardcore integration developer to develop mission critical orchestrations. Azure Logic Apps can be run in two ways. So they can be run completely on the cloud, on the common virtual machines that we can use. And it is accessible to everyone, of course, by applying proper security. But we can also run the Logic apps in a virtual network using the integrated service environment. So these are the two ways we can run the Logic apps. Then let's take a look at Azure Functions. So Azure Functions are not part of Azure Integration Service suite, but they are equally important in the integration world, as Azure Functions are used as utility functions to provide functionality that Logic App lacks or is just too complex for a Logic App to perform. So for example, let's say we have a Logic App API, and Logic App API wants to perform a really complex navigation on an array of system and compare two different sets of JSON responses from two streams. So this particular aspect becomes difficult to implement inside a Logic App. So there Azure function comes into play. We can write a utility Azure function, and we can pass those two arrays to compare to the Azure function, and the Azure function can then implement the logic inside it and return the result to us. So the Azure functions can be plugged with Logic apps through HTTP based calls, or we can introduce queues and topics in between the Azure Logic apps and Azure functions for the asynchronous communication. So we'll see one of the patterns later on. But Azure functions, so they present another side of the story of running serverless workloads. Azure functions are serverless compute which are run on the platform, and it's again completely abstracted from the developers, thus making them truly serverless in nature. Azure platform, Azure functions are nothing but just small pieces of code which run on the Azure Functions runtime platform. Azure functions have plethora of triggers and bindings which allow us to again integrate with various Azure resources, and these triggers can be triggering a function based on time, triggering a function based on an HTTP call, triggering a function based on when a message arrives in a queue or a topic, or when an event is raised by the event grid. So anything like this can trigger Azure function, and Azure function can then communicate with the other systems using bindings, be it communication with blob storage, be it communication with SQL Server, be it communication with SendGrid. So there are a lot of bindings for multiple things, and if there is no binding, it also gives us the privilege to write custom bindings. Azure functions are suitable for people from hardcore development background, as they offer the freedom to write the code according to the requirement. Now, this again gives the developers the ability to develop and debug the functions locally before deploying them to Azure. Sadly, this is not possible with logic apps. We have to test the logic apps in the cloud environment itself. Another salient feature of Azure Function is that they are multilingual and support a lot of development languages like C#, JavaScript, PowerShell, even F#. Azure Functions can also be deployed as containerized Docker apps, which I think is again awesome feature, and they also support production slots, which allow us to have functions which are highly responsible and avoid cold starts. And Azure Logic Apps, Azure Functions can be run on fixed price app service plans, or we can use consumption-based plans. Mostly with integration scenarios, consumption-based plan is used because it remains cheaper in the longer run. Azure Service Bus. Azure Service Bus is a fully managed cloud messaging service for enterprise level messaging. An enterprise messaging system is supposed to be highly secure and reliable and scalable. Azure Service Bus is highly secure, as the data traveling through the Azure Service Bus is always encrypted in transit, like the other Azure services. Then it is highly reliable, as it provides a guarantee of the delivery of messages within its time to live, and also provides the ability to manage orphaned messages. Excuse me. Azure Service Bus comes with different plans like basic, standard, premium, which are suitable for different production loads. This makes Azure Service Bus highly scalable, as we can change the Azure Service Bus plans according to our need. Azure Service Bus supports publish subscribe mechanism, which is extensively used while creating asynchronous integration, and messaging through queues or topics is at the heart of integration. It also supports the classic FIFO, that's first in, first out, which is widely used in integration scenarios where ordered processing is always required. It supports one subscriber linear communication between system using queues, meaning one publisher, there is one publisher and there is only one subscriber. Or it also supports the fan out scenario, wherein there is one publisher and multiple subscribers can consume the message. So in the fan out scenarios, we have to use topics. For single to single communication, we use queues. Azure Service Bus allows developers to establish secure integrations between the on-premises systems and the cloud systems, thus enabling hybrid integration. So this is something I'll show you during the demo section, taste of how the hybrid integration works. Then another, or the other side of the messaging part in Azure Integration Services is Azure Event Grid. So Azure Event Grid is a fully Microsoft managed routing service offered by Azure, which delivers event notification using lightweight HTTP call. The Azure Event Grid is baked in the Azure backbone, and by default, many Azure activities that we perform may trigger an event. Simplest one would be when a blob is created. So if we take a look at the image on the right hand side, we can see that there are multiple event sources. For example, blob storage can emit events like blob is created or blob is deleted. Then resource group can emit events like resource group created, resource group deleted. Event hubs have their own event. IoT hubs have their own event. Service bus emits events when there are no listeners for the messages in the queues or topics, so on and so forth. So these lightweight event notification allow us to develop event-driven solution using the publish subscribe model. So example, let's say a blob is created, then as shown in the figure, it triggers an event on the event grid. And as shown on the right hand side, we can have either the functions or logic apps waiting to listen to the event and react to it and process the blob that is created. So that's the way we can use PubSub model with event grid to develop event-driven solutions. So what this does is this and Azure Service Bus promotes loosely coupled architecture styles so that when you put in either the event grid or Azure Service Bus in between, you can decouple the systems and you can replace any one of them at any time with minimal impact on the behavior of the other. A great feature of Azure Event Grid is that not only it supports the publication of events by Azure internally, but it also allows us to expose or publish our own custom events. For example, I am writing an orders service. Now I want to publish an event that an order was created. So Azure Event Grid allows me to publish that event onto the Azure Grid by creating a Azure Grid topic and posting the event message to it through HTTP post. So it's as simple as that. And the advantage here is that we have 3 different types of schemas which we can use to create the events. One is the inbuilt Azure Event Grid schema, which is the structure defined by Microsoft. We have Cloud Event Schema, which is open source schema structure defined by Cloud Events. Or nowadays, Microsoft has given us the ability to write our own custom schema as well. Then Azure Event Grid has a very high throughput and it's almost real time. It's almost real time. It's not completely real time, but the events are delivered almost as good as the real time integration. So it's really good. Then we pay per event billing model, and hence it's really cheap. Then comes the big beast, Azure API management. So today is the world of APIs. Most of the functionality provided by organization nowadays is exposed either internally or externally to customers as web APIs. These web APIs work over simple HTTP, and they usually are REST based, or in some old cases SOAP or even gRPC or GraphQL based. When these APIs are to be shared with the users, it is important that they are exposed securely to them and that the APIs implement proper authorization and authentication methods. So this allows an organization to mask or this API management or this gateway things allows the organization to mask or obfuscate their backend APIs so that their backend API URLs are never shared with the external users. So we can create our own URLs and attach them to the backend URLs, and the front-end URLs are shared with the external people. And it's also important that these APIs are provided to the correct users and they are in an intuitive and beautiful and easy to use format. What I'm talking about here is the Open API 3.0 or Swagger 2.0 specifications for the APIs so that the caller understands what they are supposed to do and how they are supposed to invoke the web APIs. So in comes Azure API Management to rescue. Azure API Management allows us to secure it allows us to expose HTTP-based web APIs that we can create using Azure-backed logic apps, Azure functions, or even custom web APIs using Azure App Service. Since it can mask the backend URL, we can create URLs that conform to the REST or even the nomenclatures used by web APIs, and that makes them more discoverable and marketable, and we can also monetize them. Azure API Management supports product and subscription-based access to the API so that only intended users can use the API.
Mandar, this is Siddharth. If you can just repeat the Second point, when you said helps make API marketable and discoverable.
Okay, so all right. So when I'm talking about making the APIs marketable and more discoverable, what I'm talking about is when you are exposing your web APIs to the outside world, one of the requirements is that your web APIs have proper nomenclature in them. No one is going to use API which is poorly named. So that's one thing. That makes your API more discoverable for others, and it becomes marketable because people want to interact with it. Nobody wants to see weird tokens or date times or other stuff that is irrelevant to the API in the URLs. Then, as I mentioned earlier, we require an intuitive and beautiful way for the developers to interact with the APIs. So that is provided by the developer portal inside Azure API Management, which is highly customizable. So Azure API Management, through its URL masking and the other facilities, which I'll cover in a second, makes the APIs more marketable and discoverable. Then, as I said, it provides support subscription and product-based access, so that only certain users who have subscription to certain products in your APIs are only able to access those APIs. And how that pans out, I'll explain during the demo section. Azure API Management has a way to highly customize the behavior of API using the policy engine it has in place. So this policy engine again allows us to apply marketable features or to create market-ready APIs, like we implement the throttling of the calls, that a certain certain subscriber can only make 10,000 calls per minute or per 30 minutes and stuff like that. Generally what we see in the Azure cognitive services for the different tiers. Then it allows us to whitelist IPs that only certain IPs can make calls to our APIs. It allows us to implement OAuth 2.0 based authorization. So it allows us authorization code flow in the developer portal. It allows us to establish implicit grant flow. It allows us to establish credentials grant flow for OAuth 2.0, and it also gives us the ability to implement OpenID authorization as well. Then, as I mentioned earlier, Azure API Management provides a highly customizable developer portal, which basically gives access and visual ways for the APIs to users to access the APIs. So I'll cover all of these things in the demos. So that's it from the theory part. I know it's really brief, but if you guys are really interested about learning about Azure API Management in particular, I'm presenting next Thursday during the Global Azure Bootcamp on Azure API Management. So if you really want to learn about it in a little bit depth, I would request you to attend that session too. So let's move on to few demos. So this first demo is the image management workflow, and this demo is basically a demo which signifies an integration that can be developed by a non-integration developer. So this uses Azure, event-driven reactive style of programming, and the scenario pans out that we have a storage account with us, and we have an input container where some external application uploads a lot of images every day. And the requirement is that due to the sensitivity of the images or the people inside the images, we want to segregate the images into two sections, one where the images have faces in them and one where the images don't have faces in them. So we have two more containers inside our storage account, one to store images with faces and one to store images without faces. We have a logic app which is listening to a blog created event from this particular container where we upload the images. and it reacts to the that event. So when an image is uploaded to the input container, it triggers a blob created event on the Azure event grid, and the logic app has subscribed to it. So the Azure event grid basically, it's a webhook based call. So when the blob created event is raised, this logic app gets triggered through the webhook URL. Now what it does is it basically reads the URL of the blob that was uploaded into the container, sends it to the detect face API, detect faces function. The detect faces function returns an array of response whether the image was detected or not. And in order to determine how many images were received, what we do is we send that array that we received from face API to Azure functions. Azure function internally passes it and returns us the count of images received or detected. Now, if the count of images detected, or this Azure function returns that the count of images detected is greater than 0, we copy the blob from input container into the container which is images with faces, or if it is 0, we move it to images without faces. And at the same time, there is a scheduled base logic app running at the same time, which can run according to a requirement every 1 minute, every 2 minutes, 1 hour, 2 days, 3 days, according to our limit. And it's basically deleting all the blobs which are older than a stipulated period of time. Let's say I want to delete all the blobs which are older than 2 minutes. So we can configure that logic app, logic app to work like that. So let's move on to the Azure portal and see how this.
Just one thing. So just one thing, Mandar. When you said, if you can just go back to the if you can go back to the.
What's the question?
So let me just first see. So if you see here now, if you can just maximize the screen here. Okay. Yeah. So you said that if the count of the images that has been uploaded, if it is greater than 0, then you will upload that entire image to images with faces container or the blob storage, correct?
Yes.
And if it is not there, so but then the question here is there should be some intervention of functions, right, which will be doing this stuff, or it will be done through logic app.
Well, the same logic app does the same thing. Well, it's again depends upon the integration style that you want to use. If you want to break it down further into 2 logic apps, which each dealing with moving it to one container.
No. My question is different. My question is the entry to images with faces and images without faces should be done by functions or should be done by logic app?
It should be done by the logic app. So Azure function only parses the array that the detect faces provided us and gives us the final count of images detected. That's it.
Okay. And then the entry to the blob storage will be done by logic app.
Yes.
Okay.
So remember during my initial slides, I said that Azure function is not a part of integration services, but it is an important part that we need to use with logic apps, right? So that parsing of the array that detect faces sent becomes difficult when we want to use logic apps. Hence, we have a utility Azure function which basically parses that array and returns us the count. That's why the Azure function is there. It has no other. All right. Then let's move to the Azure portal. So if I go ahead. Okay, so what I have here is the blob storage. I'm inside the Azure Storage Explorer. I have my input where the images will be uploaded by the apps. Then we have a container which says images with faces, and one is images without faces. And if we go to the Azure portal, you can see that we have Azure Logic app here, which says that this Logic app is listening for a resource type of storage accounts. It's looking for a particular storage account where we are concerned about, where the images will be uploaded. And it is looking for a blob created event, and it says that only when the blob is uploaded to the input container and not the other containers here, then only I will react to that particular message. So what it does is it basically accepts the URL, reacts to the event, extracts out the URL, sends it to detect faces, and the output from detect faces is sent to the Azure function to get the number of detected faces. And to answer your question, based on the number of faces detected in image, if it is greater than 0, we copy the blob to the particular container where the images with faces are to be stored, or else we copy it to the other container. So if I have to show you a quick demo, go ahead and place my image inside the blob. So it goes into the input. So it is getting uploaded at this point of time. And if we go to our portal and go to overview, we can see that the Logic app has been run at this point of time. So it's 10:12 here, and we have a successfully run Logic app. So if we go to our images with faces, there should be an image here, and which basically is the same image that I uploaded. So it copied the blob. And let's try another image, which is just a nature landscape. So sorry, again, I'll upload this to Azure blob storage in the input. Where is it? And it should pop up in the images without faces. So as you can see, the timestamp matches with the current image time. So, and you can see it is the same image. Now, as I mentioned, there is another workflow which deletes the blob from the first container, input container. So this is the Logic app for that. What it does is it's recurrence based. So it runs every 3 hours. And what it does is it lists the blobs inside the input container in that particular blob storage account. And it filters out all the blobs which are older than 1 minute. So it takes only those blobs which are older than 1 minute, and basically on each of them it runs the delete blob action. So if I go ahead and manually trigger this, so you can see that it has succeeded now. If we go back to the input container, refresh it, we can see that it's gone. So that's an easy integration where I developed the integration with a minimal external use of Azure functions. So it's a really easy integration to implement, even if you are not an integration specialist. So that's one. And next demo is my intelligent feedback analyzer. Before I share this demo, what I will do is prep it up. So what I'm going to do is I'm going to compose a mail to the mailbox that I've prepared for this demo. I'm going to say feedback for my state. So this is a feedback mail that I'm sending to my mailbox. And by the time I explain the scenario, we'll see what happens. So I'll move back to my slideshow. So again, this integration is a modern day integration which presents itself because we integrate with Azure cognitive services here. So the scenario is pretty simple. We have a feedback mail message box where we are expecting users to send feedbacks, or we were either through mail or their feedback forms. So we have a logic app which is listening or polling that particular folder in the mailbox. Every n minutes, we can configure it according to our needs. And what it does is it picks up all the messages that have received between that window, extracts the body from the mail message, sends it to analyze sentiment function of the text analytics API, retrieves the sentiment score, and basically saves the feedback and the sentiment to Azure Cosmos DB, so that at a later point of time, someone from marketing can go through all the feedbacks that are received and they can understand understand and go through the feedback. I'm not sure. There's some background noise. Thanks. It's better now. So this is a real modern day integration scenario. So let's move back to Azure portal. So what I did was basically I sent a mail to this mailbox that is monitored by Logic Apps. And if we move to our resource group here, change the filter to intelligent workflow, and there is this Logic app which basically analyzes the feedbacks. So what it does is it polls a particular inbox that we configure using the connections. So this is the mail ID that I've configured. And it says that poll this inbox every 3 minutes, and we can save or configure other items as well, whether it's of high importance or low importance, whether it includes attachment or not. Then whatever mail that we receive, it gets its body and sends it to Text Analytics API, and it retrieves the detected sentiment. And it then creates a partition key for the partition key for Azure Cosmos DB. And basically what it does is it creates a record inside the Azure Cosmos DB. So let's see if we have a recent run. Okay, so you can see that the function app ran at 10:16 p.m. and just to be sure, you can see that it is the mail that I just typed. Hi there, I really enjoyed my stay and I recommend it to others. So what it did was it got it. It sent the message to detect sentiment. The detect sentiment returned that it had a 87% positive score. So what we did after that was we straight away inserted it into the Azure Cosmos DB. So if we go to the Azure Cosmos DB, go to Data Explorer, and that should show us the item that we just created. So we can see that this is the message that I just sent. So this way this is a modern day integration, and again it required no setup whatsoever. So a normal developer who has no expertise in integration again can do this. So that's the beauty of Azure Integration Services. Now, moving back to the next demo, this would be a little integration heavy demo. So it's basically shows us how to create a microservice. Again, I'm using the age-old orders microservice example. So the way this demo works is that we have a website which creates orders or which is a shopping website. It requests order from the person or customer that visits our site and accepts the payment. And after that, what it has to do is it has to save that order into the orders database. So the orders microservice really has only two tasks. One is to process the order and save it to orders database, and another one is to provide a way to retrieve orders based on the customer ID that we provide. So the first logic app to create the orders, or the process to get the orders into the orders database, is broken down like this. So we have a publish orders logic app, which is a two-way HTTP post based logic app. It accepts the order details from the shopping website, and it creates a order correlation ID and returns back the correlation ID and the customer ID back to the front end with a status of 202, meaning that it has accepted. And once that is done, it publishes the order details onto Azure Service Bus order input topic. Now, order input topic has a subscription from the process order logic app. So the task of this process order logic app is just to subscribe to the messages published onto the order input topic, process them, and create an order in the orders database. And once that is done, publish another message onto a different topic, which signifies that the order has been processed. And once that order is processed, then there is another notifications logic app which subscribes to that message and sends out the notification to the customer who placed the order. So that's the publish order orders logic app. So if we want to take a look at it, and let's cover the retrieve part as well. So retrieve part is simple. We have a two-way HTTP post. Basically, we provide the customer ID, and the logic app goes to the orders database, retrieves the orders for that particular customer from the database, and then converts the OData JSON that the logic app returns into a more user-friendly JSON and sends it back as the response with the 200 status. So that those are the two services. One is to publish or create the orders, and one is to retrieve the orders. So if we go to the logic app, the portal, let me change the tag here again. So microservice. So as you can see, we have the publish orders logic app. This publish orders logic app basically accepts the order message, which has customer ID, order details, payment details, and promo code. It sets up a correlation ID called as order ID, creates the order message, which is basically taking the entire message it received and adding the order ID to it, and sends this message to the topic as we just saw. And it returns HTTP 202, meaning that it has accepted the order for processing. So once this is done, we have a process order logic app, which basically polls the topic every 10 seconds. And what it does is it basically is working with this subscription, which is exclusive to this logic app. It gets the response from the service bus. Since it's encrypted, it decrypts it first and then parses it into the message, which contains customer ID and order details and so forth. And it again, at last, inserts it into the SQL server, where it stores the order ID, the orders, customer, payment mode, and whatnot. Once that is done, according to our flow, it sends out another message to another topic, which is basically processed order output topic, which indicates that the order has been processed. And we have another logic app called as a notify customer logic app, which basically again subscribes to that particular topic with this exclusive. Now this one is running at 1 minute because we can notify the customer a little bit late, whatever. And then it again parses it into the proper message format, creates a HTML table of the orders, and once that is done, it goes to a table API where the customer details are stored. So I just have a table API here, but in real life, we can have Azure Cosmos DB or any NoSQL table to store the details of customers. So here I just have one customer at this moment. So we have the customer key here and the email address and the name. So it picks up the customer details from here based on customer ID and sends out a templated email by populating the values like the order ID, the amount, the mode, the output. And it marks the message as complete so that the same message is not picked up when the Logic app again pulls the messages from the Azure Service Bus. So if I go ahead and take a look at how this orders API work, so I'm going to call the Logic app publish order. Now, as you can see here, the URL that I have is really contrived here. It has a lot of signatures in it. It has API version in it, and it has triggers and other details about the Logic app. This is not ideal when we want to expose it out to external customers, because first it gives out the signatures that we are using to authenticate with the Logic app. And second, the URL straight away is ugly and it should not be shared with the external world. So this is the Logic app URL. What I'm doing here is I'm feeding it a orders message where I say that order I want to order, let's say, Harry Potter books set, and I want one, and let's say that the total for it is 50. What I do is I basically just send it, and it should create a 202 accepted, and it creates an order ID for us. Now, if we go to the portal and we go to our publish order Logic apps, you can see that it was triggered at this point, and we can clearly see that it has to publish a message onto the topic. So this means that the publish order Logic apps should process the order. And we can see that again, this Logic app as well has picked up the message and inserted it into the SQL server and marked the message as complete and published it onto another topic. And that should mean that the notified Logic apps should have also fired by this point. And we can see that, yes, indeed, that was the case. Let me see if I have received the mail. Okay, so you can see that the mailbox to which I have configured in the table API, I received a mail. Hold on, my bad. Yeah, here is the. So I just received the email here. Says that confirmation of order ID, blah blah blah, and it says that amounting to AUD 50 with COD as the mode of payment and Harry Potter's book set 1. So the end-to-end microservice has worked. Now, if I run the code to retrieve the order from the database, all I need to do is just pass the customer ID and it should retrieve the orders for me. In the meantime, we'll go to the portal quickly, go to retrieve orders Logic app. And you can see that it's still running. The integration account sometimes takes time to transform the message. So let's wait for a second. All right, so it's done. And we can see that the response we have received indeed has the last order that we just placed, Harry Potter book set quantity 1. So these, again, as you can see, are the URLs that are really ugly, and we don't want them to be exposed to the outer world because they are not fully secured. So anyone who gets the access to these keys can just run the Logic app. But another point that I want to show you before that is, so for example, when I did a retrieve of order from the SQL server, it returned the format in the returned the data in the OData query format, which is not user friendly. So it has this OData E tag, OData context, and everything. In real life, we don't want the front end users to see that. So what that's what we do here. We call a transformation here, wherein we basically take the OData details and transform it into the beautiful JSON structure that we see here. So that map looks something like this. So it's basically reading the details from the incoming JSON and creating a new JSON structure of its own. So this is a deep integration concept, so I'll not go into that much depth here, but that's what the integration account that I talked about earlier is used for. Now moving on quickly, as I said, these URLs are not secure to be exposed to the external world. So we mask this URL using Azure API management. So let me go to API management services quickly. And here in the API management portal, what I have is basically a orders API. And it has 3 operations in it. One is process order, which corresponds with processing the order. One is to retrieve the order, and the third one is to accept or get a token for the order. So what I've done here is that I have implemented OAuth 2.0 client credentials on the process order and the retrieve order operations. So basically, one has to get a access token first, based on the client ID and client secret that I share with them. And after that, they can call the operation. And inside the operation, what we do is we basically validate the token that the front-end caller is sending, that whether it matches with the client application or the application that we have. So I'll be discussing all these things in detail in my Azure Global Bootcamp session. So again, if you are interested, please join me there. So quickly, if I go to the orders API section, and now as I said, it works with subscription ID. So whenever you want to call a API that is exposed through Azure API management, you need a subscription ID in the header. So let's say when I want to retrieve an order based on customer ID, so this is the masked URL that we have. So it's way different than what the retrieve logic apps retrieve orders URL was. So if I just send it, it says that you are unauthorized due to missing subscription key. So this is one security feature. Now let's say I pass the subscription key in here. It's configured here in the environment variables, but I have not passed the access token. Again, it sends me a 401 unauthorized error because I have not really authenticated myself to that operation. So what we do to get the details are, we set the header subscription key in the header. We set the body with client ID and client secret that the publisher of API shared with me. I call the token endpoint. I get the token. It's a bearer type of token, expires in 1 hour, and it internally contains the details which I want to use while authenticating to my operation. So once that is done, I go to retrieve orders, and as you can see in the headers, now I have the subscription key and I have the token that I just queried from the token endpoint. Now it's fully authenticated and it's fully set up. Now what we just do is pass the customer ID and it should give us the order. So we have successfully authenticated with it. At the same time, if you want to process an order or create one, again, pass the header as subscription key, the authorization key, and we just add a new book here. Quantity 1, BPay, let's say, yeah, say it's $6. And we just send it. And it again gave us the order ID. And if I do a retrieve orders, it should pop up here. So yeah, hold on, tale of two cities and quantity 1. So this way we have beautified our URLs for the services, and not only that, we have implemented a lot more security on it. Based on additional security, we can implement IP filtering and everything, but that's out of scope for this session. And the last demo that I quickly want to show is a hybrid integration demo. This one should be a fun one. So hybrid integration is an integration which happens when some of the components that you want to integrate, some of the systems are in the cloud, while some of the systems are sitting well behind your firewall on the premises of your organization. So this is a demo that I've created for that. And now this is a really contrived example, but it has a HTTP triggered logic app, which basically takes the first name and last name and returns appended name as first name plus space plus last name. So what it does is it basically goes or hands over that call to a WCF service that is deployed on my laptop at this moment. So it's basically on premises. So the logic app has a custom logic app connector which goes through the on-premises data gateway, communicates with the WCF service that I have on my laptop, passes the first name and last name, creates the full name using first name plus space plus last name, and returns back the response. The response returned back by this WCF service is XML. So what I do is, again, I use a transform to read through the XML details and parse it into a usable format JSON. So the service that I have here is, it's basically hosted here. It's a name appender service. As the name state, it does the same thing. So through a SOAP UI, if I pass it the first name and last name as Robert and Baratheon, and that should give me a full name as Robert space Baratheon. So this is what we will test now. So on premises, now I have not secured this through Azure API Management by Gateway because I've already shown that demo, but the same principle applies to this too. So we pass the first name as, yeah, we'll keep it as John's and last name as no. Let's just send this. And you can see that it has returned a full name of Jon Snow. So if we go to the portal, so what it has done is basically it has received the first name and last name, and it has created the XML structure here. You can see this is a SOAP-based service, a really old format, and it basically passes it to the custom logic app connector, and whatever response that we get from here, we feed it to the map which transforms the response into the full name, and we return the response back. So in the overview, we can see that we received the first name and last name as John and Snow. We created the XML structure that we wanted to feed to our WCF service hosted on premises, John and Snow. And if we check the outputs, it returned the XML to us in the SOAP body format. Hold on, sorry, my bad. So here we passed the XML, set the content type as text/XML, SOAP action as whatever operation name that we have, and it gave us a SOAP envelope back with the full name as Jon Snow. So what we did after that is transform this XML into a JSON and just basically returned it. So that's how the hybrid integration pans out in the real world. It's not a exact real world scenario, but it should do the time being. So back to the presentation. So that's my demo. Reading resources, again, plain and simple. I would encourage you to go to landing pages of each of the products and start from there. It's a really great way to learn different things about it. The last link is a link to 2008 build session given by John Fancy from Logic's app team and Dan Razonova from service bus and messaging teams, and it tells you how to be an integration hero. So it's a bit old session, but the concept still holds true. And I think that's it from my end. If you have any questions, now I'll take them. Thank you.